everyone, welcome to another video where here I am with another interesting topic in this paradigm of linear algebra and matrices called as the echelon form of matrices, right? So before we understand what this echelon form is, let's try to first get a glimpse of why do we need this in the first place, right? Say like you're solving a set of linear equations using matrices, right? Like you have something like 3, 2, 4, 1, 6, 8, and then 2, 1, 3, and then you have x, y, z. So the first thing becomes 3x plus 2y plus 4z equals, this equals 0. All of this, right? Let's see. We let this, something like that, right? 3, 2, or 1. So equals 3, and then x plus 6y plus 8 equals 2, and then 2x plus y plus 3z equals 4, right? So instead of having all of this, right, don't you think life would be easy if you had a matrix in this kind of a form where you had just one digit here, like say 0, 0, A or something, or like say 0, B, C, and then uh, like say D, E, and F. So like straight away, what you get is like AZ equals something like say 3, right? So you get the value of Z straight away, substitute this value of Z here, and then you get the value of your Y. And then from this X and Y, you get your value of your Y and Z, you get a value of X as well, right? So like this kind of a staircase pattern really helps you quickly find out the values of your variables, right? That's exactly why you need the something called as echelon form. It's like a way of tidying your uh, matrix, right? Tidying your matrix in such a way so that it gives you the relationships between the variables really upfront, right? That's basically the echelon form of matrix. Now, this echelon form of a matrix can be of two types. One is called as a row echelon form, also abbreviated as REF, and the other one is called as a reduced row echelon form, RREF, right? So inherently, both of these are meant to give you the same objective, but there's a slight difference between the two. The first one, row echelon form, basically needs to have these prerequisites. Is that the first one is that all the rows which contain all zeros, right? Like suppose in a matrix we have like rows like say 3, 1, 2, 0, 0, 0, and 1, 6, 8, for example. So this is not an echelon form because these all zero rows, they have to be at the bottom, right? So all zeros have to be at the bottom. Suppose you have a matrix called as 3, 1, 6, 0, 2, -1, and then 0, 0, 0. So here all the zeros are at the bottom. So this satisfies the first condition of an echelon form, right? That all the zeros, if you have any rows which are all zeros, and they have to be at the bottom. That's the first condition. But still, this is not an echelon form matrix because the second condition requires to be fulfilled is that this condition talks about the pivot value. So what are the pivot values? So consider the matrix here. Let's say 3, -2, 1, 0, 1, 6, and 0, 3, 1. So you see this in this second row, the first non-zero number is this. All right, that's called as a pivot. All right, over here in this row, again, the first non-zero number is this. So the first non-zero number in any row is called as a pivot. These two are pivots. So the prerequisite for an echelon form is that the pivots from subsequent rows have to be at the right of each other. So if you look at this matrix now, let's say 3, 0, 2, 0, 1, -7, 0, 0, 5. So you see, in this row, this is the pivot. In the next row, this is the pivot. And in the next row, This is the pivot. So you see, the pivots from subsequent rows are to the right of each other. So this one is to the right of this one. This one is to the right of this one. So they are the right of each other. So pivots from subsequent rows have to be at the right of each other. Right? Let's take another example. Let's take a 4 by 4, a 3 by 4 matrix this time. Like say 3, 2, 0, 7, 0, -2, 1, 0, 0, 0, 0, 5. So even here, this is the pivot in the first row, this is the pivot in the second row, and this is the pivot in the third row. So you see, this is to the right of this, and this, even though there's a displacement of one place here, still it's at the right of this, right? So this satisfies the second condition. But here, the first condition, if it's satisfied, then this would be an echelon matrix, right? So that's the second condition of an echelon matrix, of a row echelon form. So now using these two conditions, let's try to assess whether some of the matrices under discussion are echelon forms or not. So let's look at this one. 2, 0, 3, 1, 0, 0, -2, 0, 0, 0, 0, 7. Right? So now we have to assess whether this is a REF, row echelon form. So the first prerequisite is that all zero rows have to be at the bottom. So there are no all zero rows here, so we can ignore the first condition, right? The second condition is that the pivots have to be at the right of each other, right? So here, this is the pivot number 1, here is the second pivot, and here is the third pivot. So we see that they're all at the right of each other. So this matrix is definitely a row echelon form, right? Let's take another example. 0, 6, 7, 2, 0, 0, 3, 1, 0, -2, 0, 0, 0, 7, 8, 0, 0, 0, 0, 0. All right, so here, is this an echelon form matrix? If you want to assess that, you see that the first condition is being satisfied, right? Like all the zero rows are at the bottom. So now let's check the second condition. In this row, this is the pivot. In this row, this is a pivot. In this row, this is a pivot. So you see, like these two pivots are in the same line. They're not at the right of each other. So this main matrix cannot be a row echelon form, right? All right, that's basically row echelon form for you. And now the second one, which is a reduced row echelon form, is a slight modification, in fact, a slight simplification of the row echelon form, where obviously all the prerequisites of the REF are also valid to the reduced row echelon form. But then there are a couple of more conditions, is that all the pivot values have to be 1, right? So like say 1, 0, 3, -2, 0, 1, 0, 7, let's say, and 0, 0, 0, 1. So here, the first one is a pivot is 1. This is also 1, and this is also 1. So all the pivots are basically 1, right? They have to be nothing else apart from 1. The second prerequisite is that of a reduced row echelon form is that all the rows in the column where the pivot value resides, all the other elements in that column where the pivot value resides, they have to be 0. So you see here, apart from 1, all other elements are 0. In this column as well, apart from this 1, all other elements are 0. But in this column, apart from this 1, you do not have 0 elements. These are non-zero. So this is not a reduced row echelon form. All right, let's take another example. So let's say 0, 1, 0, 7, 0, 0, 1, minus 2. And well, let's make this. Let's modify this to make it an echelon form. Right, so let's say 0, and then 0, 0, 0, 1, right? Now you see this in this row, this is the pivot. In this row, this is the pivot, and in this row, this is the pivot. So they are all right of each other. So the condition of being a row echelon form is automatically satisfied since we have no non-zeros. Since we have no zeros, we have all non-zero rows. The first condition doesn't exist here, right? And then now if you look at the eligibility for being a reduced row echelon form, you see all of the pivot values are 1, and then all other values in that column apart from the 1 are 0, right? So this is a reduced row echelon form, right? So now you see you have all these ones in a slanting direction. So someone might have a valid confusion that is it that all the RREFs are like identity matrices? Right? That's a valid confusion, right? The answer is sometimes yes and sometimes no. So you see, is this an identity matrix? Obviously not, right? Because it's like it's a 4 by 3 matrix. So this cannot be an identity matrix, right? Suppose this was 4 by 4, then in that case, this would have been an identity matrix, right? So an identity matrix, all identity matrices are reduced row echelon forms, but all reduced row echelon forms are not identity matrices, all right? And all reduced row echelon forms are also row echelon forms, but all row echelon forms are not reduced row echelon forms, right? Clear? So I hope this discussion was helpful to understand the REF and the RREF. I hope you have found this video useful. If yes, please like the video and please add your comments at the bottom of the video, and please feel free to subscribe to the channel and share this with the interested folks. In a similar way, I shall come up with another interesting video on similar such topics in mathematics. If you want me to create any videos on the topic of your choice, just feel free to write to me on the avenues within this channel itself. Until then, I wish you best wishes with your preparations and your learning. And until then, take care. Bye-bye. If you like this video, please press the like button. For more such videos, subscribe to the channel. If you have suggestions for a new topic and would want to see a video made on that topic, please feel free to comment in the comment section below. Thanks for watching the video and see you in another video. Bye-bye.